today, my goal will be to do a couple of things. First of all, to show you where on university system you can find your courses, and that will include this recording. And then to the reason why you're here, I'm going to give you a gentle introduction to Python, such that you can start playing with it before the semester starts. So then you're going to hopefully feel more comfortable once the semester starts. If you have some questions, you can ask them on the chat. I'll try to answer the question and, without making huge interruptions. Hopefully you can hear me well, and hopefully there won't be a delay in my speech and my video and my coding. We're going to code together today as part of this tutorial, but I am on a phone internet, so it may at some point freeze up a little bit. Hopefully not too much. Hopefully it will be okay for you to follow. And maybe in the meantime, the home internet will rise. So, as luck would have it, the home internet stopped working 15 minutes before this is meant to start. So hopefully my phone internet will be enough for us to have this tutorial today. Okay, so let me start with the first thing. Where can you find your courses? And don't worry if you don't see any of your courses. Some of the professors haven't made their courses visible yet. Okay, but some of them may have, and you may already have some useful information there. Okay, so the way you do that is you can go to Google and type Brightspace U Ottawa. Okay, and you will see the link here. It says virtual campus or Brightspace for students. So that's what you need to click on. And then you will be able to log in with your credentials to Brightspace. And typically all of your courses will be there, meaning professors of the courses will place the material there, and including assignments and the lecture notes and so on. So on this web page, you see here, you have a link, virtual campus login page. So you click on that. I can click on that, but I am already logged in. I'll show you what that looks like. And it will ask you your credential, which hopefully you have your credentials, your login name, which is typically your email, university email. But I'm already logged in because I made sure at least that is working if my everyday internet is not working. So one of the things that you're going to see, by the way, I did not introduce myself. I am a professor teaching two sections of this course, ITI 1120. We'll be teaching sections A and B. So some of you are registered in my sections, and some of you, let me show you. So my name is Vida Dujmovic. I'm professor of computer science. And so those of you who are in section A and B, you will have me as professor in your course. Those of you who are in other sections will have somebody else. But don't worry about these recordings. I will ask the other professors as well to make this recording available so you can have it. So no need to ask notes. And if you need to leave early, that's fine. You will have access to this. This tutorial, at least, some of you are in French section. This tutorial is only offered in English, but even your professor, even if you're in French section, I will ask French professors to upload this, to make this video link available for your courses. So once you log into Brightspace, at least those of you who are in my section should already be able to see the course. It is called ITI 1120 AB Fall 2020. Okay, so when you click on that course, what you're going to see, I have a professor view, it's kind of different, but so I'm going to switch to student view, and you will be able to see already some material not really material. There's very little there right now, but there is something important for all sections. So I'm going to show you, it's not a reading list. If you want to go and read ahead, that's fine, but that's not what I wanted to show you. It's actually, what's the name of my YouTube channel? There's a question there, as you can see. Sorry that I'm kind of going to be jumping back and forth between your questions and me explaining things. So what you can do is you can put my name without this apostrophe here, and YouTube is going to take you to my YouTube channel. Most of my videos, there's many, but they are unlisted. But this tutorial, I will make it public. So by sometime, let's say tomorrow afternoon, if you just go directly to my YouTube channel, you're going to find this tutorial as a public on my public YouTube webpage. Okay. So if you go to the course, to the Brightspace, you can already see that I have made an announcement for students. And this is actually relevant to all the students. Hopefully, your own professors already made an announcement. And that is just to give you an idea that, it's already pays off to start looking in Brightspace to get familiar with where the material is, and it has the professor shared any information so far. So far, I have only shared this information here. So you can click on announcements of the course, and you can see that on August 13, we managed to book the room and decided on the dates for your midterm. So please make sure for all the section, French and English, no matter who is teaching you, you're going to have a midterm on Saturday, November 3rd. Sunday, November 3rd, from 9 to 10:30 in the morning. So this is just kind of to show you, put it in your calendar already, but just to show you where you will be able to find this information. But not just announcements. As I mentioned, you're going to be able to see all the material. I, in particular, record all my lectures throughout the semester. I put a link there so I can show you what that looks like from previous year before we start the lecture. I just wanted to make sure that you know about Brightspace, that you know to log in, because being informed is also a way to start feeling more confident and comfortable and prepared to know what to expect. So this is my 2023 course. And for example, all the course material is here. This includes the lectures. You can see here 59 lectures and lab. And each of the lectures, including tutorials, or workshop today is there. So all the lectures are there, for example, what type of a code that we do and coding class and what we learn, to the links to the recordings of the lecture. Okay, so this is to introduce you to Brightspace, and don't panic if you don't have any courses yet. I mean, this really depends on the professor when they're going to make their course public. Okay. There's another question. Oh, this was already answered. All right. So I don't know why. How do I make this answer live? Type answer. Okay, done. I don't know what this means. Okay, it's at least click now as answered. All right. So, okay, so let's move on. Unless there are any other, so this kind of logistics about what you can expect, but let's actually move on to the topic of this tutorial, which is going to be a gentle introduction to Python. It's really meant for those who never programmed before, right? So, but if you join this and you have programmed before, at least you haven't programmed before in Python. But if you did program in Python, maybe you'll get something out of this as well. It's up to you to decide. But the idea, it was really for those who haven't programmed, in particular who haven't programmed in Python before, to give you a chance to kind of start ahead of the semester. And even after this tutorial, you can start playing with it. And it's going to make you feel more comfortable and more confident once the semester starts. Oh, yes. So there is a question in chat. And that is about which computer to buy. And it's really a type of question that I get basically always. So my answer is I have really only 2 devices. You can get any computer you want, but make sure it's computer. What I mean by that, make sure that your computer is running a proper operating system. So either Windows or Mac operating system or Linux. So when I was a student like you, I used to use Linux. So these are operating systems on which you can properly install programming languages and any other type of software that you may use at university. So what I do not consider to be a computer are these mobile devices like iPad and phones that are running mobile operating systems like iOS and Android. So make sure you're buying a computer. And by that, again, I mean you're buying something that has a proper operating system installed, or like a computer or laptop operating system installed, Mac OS, the Mac operating system, which is basically based on Linux, Windows, or if you want Linux, you typically have to install it yourself. All right. So, and basically as long as you meet those requirements, this is going to be enough for anything you're going to need in the next 4 years of university, or 5, no matter, depending what program you're in. But another thing I would suggest that you keep in mind is that most classrooms don't have electricity plugs, and that actually having a long battery life is something you should go for. So that will be frustrating if you have a short battery life and your computer is useless if you don't have a battery life. So get any computer, any operating system you feel comfortable with, and it would be good enough. And again, focus on battery life if you can. Those of you who like to write notes, they have these computers where you can both take notes and then open it, have a normal computers. Those can be quite useful for students, I think. So you can use it both for writing notes and for actually doing coding. So this is something you may consider. So another question is whether we're going to be just learning Python in the first just learning Python, or there will be other programming languages. So in your first semester, so in ITI 1120, everything will be in Python. So in those of you who are in computer science, in software engineering, and in all of you basically who will be taking next computing course, which is ITI 1121. So that's in the winter semester, starting January. The second programming course will be in Java. So by the time you finish your first year, you will feel proficient. And, in fact, after the first year, many students, especially like software engineering students, have a mandatory co-op. They will already be, proficient enough and good enough in Python and Java to be getting programming job after their first year in the program. So in the first semester, you're going to be coding in Python. In the second semester, you're going to be coding in Java. So somebody is already asking a question that I answered, which is, where can we log into the Brightspace? So, this advice is valid throughout your university. Just Google it. As I showed you at the beginning, you type Brightspace, University of Ottawa, and first or second link is going to be the one where you're going to find the login page for the Brightspace. And I definitely encourage you to log in, right? This is something that is very important in order to stay on top of the on top of your material. So, okay, I believe I answered all the questions that are currently displayed. So let's move on to, okay, so I think I answered all of these. All right, so let's start. So first thing first, you need to install Python, unless it's already installed on your computer. But even if it's already installed on a computer, I usually just install the newest version each semester before starting to teach. Okay, so okay, so there's a question here. So I kind of should try to either move with the material and make some breaks to answer your questions rather than constantly interrupting myself. I'm not saying you guys I'm interrupting myself by looking at your question. Let me answer this question for now, then we're going to be doing something for 10, 15 minutes, then I'm going to look at your questions again. I mean, I think that makes more sense. The question is about, what about computer engineering students? I mean, it's really up to you. If you are in software engineering programs, if you are in any of these computing programs, including computing engineering, you may be in co-op. In most of the cases, in co-op starts after the second year. It's only software engineering where co-op starts already after first year, but nothing stops you from finding programming jobs or trying to find programming jobs yourself. I had many students who find jobs by themselves who were not part of the co-op. Co-op is super helpful because they have connections, they have jobs, they help you with interview, they help you with CVs and everything. But if you don't have co-op in after your first year, you definitely, if you're interested, should try to find a job for yourself for that period. Okay, so let's now start with the material. So let me first show you where you're going to find Python and what to install. So again, you're going to go to Google, which at this moment I'm in Safari, and somehow I'm just going to type the search up in the search bar. So what you're going to look for, you're just going to type Python in Google, and you're going to see as a first answer, at least in my case, hopefully in yours too, is python.org. So this is official webpage that of, organization of people who are developing Python. That's where you want to go. You want to install Python version from python.org. Okay, so you go there, and once you go there, you look at this downloads button. That's where you want to go, and you want to download Python. Okay, so most of these web pages are smart enough to recognize what type of computer you are on currently. Okay, so I encourage all of you to right now install Python. So in that case, as we do this tutorial and write our first program, you can code yourself, you can run your first program. I will be asking you, okay, instead of drawing this, try to draw this with your program. So it will be helpful if you install Python and start coding with me. Okay, so what you're going to do is in my case, it recognizes that I have a Mac, that I have a particular Mac operating system. So that's what I'm talking about. You want a real operating system. If you click on this link, it's going to download the Python package for you. Okay, so you install it. I don't want to click on it. Normally I click on it and even show you the installation, but I don't want to click on it because I'm on phone internet. I'm afraid that you are going to lose the normal connection with me. So you click on it and you click to install it. Okay, so I'm going to give you all a minute to do it. In the meantime, somebody raised a hand. I'm not even sure how to give permission to for students to kind of speak. So probably it's the best for a person who have a question, who raised a hand, to put a question, to ask a question in the chat. Okay, I'm going to answer this particular question while you guys are installing Python. So go to downloads, install, and install python.org. So I already answered that. There's a question in chat about ITI 1120 versus ITI 1520. ITI 1520 is the same course, just in French. Okay, so all of the things that I'm saying apply to you. You're just going to have a different professor, and your course will be, they will be speaking in French, but you will be coding in Python. Okay, so hopefully by now you all installed Python. So you clicked on that, this thing here, Python 3.12.5, you clicked on it, you clicked on a package that downloaded, and something got installed. Okay, so now that you have Python installed, let's try to write our first program. Okay, even just from this word, I'm going to write my first program. That implies that there is somewhere where you should be writing commands, where you should be writing that program, okay? So there are many little let's say, additional packages, additional. Yes, thank you, Andrew. Yes. Okay, so with us, we have a technical person who will allow you to ask questions once you raise your hand, if you want to pose a verbal question.
So would you like me
All
to
right.
allow, sorry, Lee, would you like me to allow
Sure,
Luke to do it
yes.
now? Okay, Luke,
Sure, yes, thank you.
Luke, I'm gonna allow you to talk. Hopefully it works for you.
Okay, Luke, go ahead.
Just unmute yourself, Luke, and talk to us. If this doesn't work, we'll have to try again later, perhaps.
Okay, no problem. Or they can type in the.
Yeah.
All right. So what we're going to do is going to write our first. You will need the little program, not little program, as a part of Python. There should be some window, and this is where you're going to type your code. And this goes back actually to another question that was there. And the question is, oh, are we going to use a PyCharm, or are we going to use this or that? For those of you who are unfamiliar, this is a little piece of software that allows you to type in your program. Okay, even if what I'm saying doesn't make sense, don't worry about it. And I want to warn you now, not warn you, for all of you who don't know what IDE is, what PyCharm is, I want to say something that you're going to hear me repeating throughout the semester. For those of you who don't know what these words are, please don't get intimidated. Programming languages are full of fancy words, full. And most often, 99% of the time, these fancy words mean something trivial. So don't worry if you don't know what these words mean. With the time, you're going to pick up this lingo. It's not important. What's more important is what is going to be the goal of these courses is that you develop a way to be solving computational problems, and we're going to get to that. Okay, but first thing first, you do need to be able to type somewhere these programs. And if you install Python from this link that I just showed you, it comes with a very simple, these are called editors, where you're going to be typing your program and where you can also click a button to run a program. The one that comes pre-installed with this Python, it's called idle. Okay, so we're going to be using idle. And those of you who prefer some other editor, some other IDE, integrated development environment, again, don't worry if you don't know what that means. You can use any one you want. But if you don't know what it is, and if you don't know where you should be writing your program, we're going to be using, for the rest of you, we're going to be using the one called idle. So after installing Python, your next goal, okay, I misspelled that. Your next goal is to find a program called like this, idle. Oh, you already see it on your screen. Okay, so I know how to find things on Mac. Hopefully you know how to find things on the machine that you have. Maybe you have Windows. So on Mac, you have this search button on the top, and you type this idle, and you can see it found this app. That's the app where we're going to be typing our program. So once you find that app, click on it. That's what we're going to be writing our programs in. So type in any search. I don't know if you have Windows, how you find it. There must be some search button, or you go to your applications and find idle, because it's, if you install this Python, then idle is installed. All right, so you find it. I don't know how to do it in Windows. I've never had Windows machine. When, as I said, as a student, I had Linux, and then like some point I became lazy and switched to Mac. So there it is. I clicked on that idle, and, or maybe I didn't. I did, and you see this big white window opened. Okay, let's see what opened here. Okay, so this is what should open. Something like this, like this. Let me hide everything so that you can see exactly what. All right. Okay, so a window like this, you should see a window like this. Okay. So if you have problem installing this from python.org, I suggest that you can try a trivial fix, is that you re-download the package again and install it. If it's successfully installed, then you're going to be able to find idle and therefore Python indirectly through it on your machine. If you still have problems, second time trying to do this, don't worry, bring your computer to the lab. We're going to have labs basically in the second week of class. The labs would already start. You can bring your computer and the teaching assistants will help you with installing. And at least for today's lecture, you can just listen and not necessarily type along if you have problem finding idle. Okay, so let's see what this is. One thing to notice when this window opened is that there are these three arrows, okay? And this should tell you, it may now be strange that I'm focusing on something so small, but it's gonna help you differentiate between two types of windows. We're gonna be working with two types of windows. One, where you're typing your code, and another where you display, which is like your window into the Python. Another window where the results, when you run your code and the results of your code are displayed, this is that window where you're going to see your results of your operation. So in some ways, if you see these three arrows, it's almost like imagine you are in the engine of Python. You are actually inside of Python. You can even ask Python, oh, let me see what this Python knows. And you can type things like 2 + 4 and press enter, and you see that Python knows what 2 + 4 is. Okay, you can ask it 2 times. You can ask 2 times 9, and you realize, okay, it knows how to multiply two numbers. Okay, so if you see these three arrows on this window, that means you are kind of in an engine of Python. This is your window into the Python. You can already there run the Python commands. In fact, one thing you should pay attention actually is the first, what I highlighted here is the first, what it says first at the beginning of the window. It says Python 3.12.5 because that's the latest Python that I installed this morning. So what you want to make sure is that it says Python 3 point something. That is important because there is an old version of Python. So maybe you have an old machine where Python was pre-installed. There was Python 2 before Python 3 a number of years ago, but really depends on what's installed on your machine. Make sure it's not Python 2. It doesn't matter what you have after 3, after that number 3, whatever you have is fine, but make sure it's 3 and not 2, because 2 is really this new Python, Python 3, that's what we're going to be using, and Python 3 is not backwards compatible with Python 2. So once you see, open this window. By the way, this window where you see these three arrows is called shell. This kind of your window into the Python is called Python shell. And when you open a Python shell, make sure that you see that it's Python 3 and not Python 2. Okay, so let me visit a little bit. All right, so I will answer the questions about the labs. Your first class, depending which section you are, the classes start on Wednesday. So that first week, at least those who are in my section, and I believe it's like that for all the sections. So classes, you have Labor Day, then you have a Welcome Day, which is a Tuesday, and then classes start on Wednesday. So somehow that first week, you have a 3-day week. You're not going to have a lab in my course. I don't know if you're taking chemistry, if you're going to have a lab. I don't know. They're going to tell you in the first class. Make sure you go at least to your first class. And so at least in ITI 1121, you're not going to have a lab in those first 3 days, even if your calendar says that you do. The labs will start the Monday after, okay? All right, so now we opened the shell, and so where do we type a program? You need to, so once you clicked on idle, you're going to see this window, but this is not where you typically type your program, although in a sense 2 + 4 is already a trivial program. You know, you wrote a program to add two numbers. Normally you want to open a completely separate window where you're going to write your code. This is going to be just an editor. Editor is a place where you write your text. The way, you know, when you're writing your email, you're actually using an editor. You need an editor to be typing all of these. So idle, for example, and basically all of these little softwares that allow you to write a program and run a program, they have editors as part of them. So here's where you find it in idle. Okay, so pay attention to how you get a different window. First of all, you find a menu. In my case, the menu is on the top. You see, here's an idle menu. And next to it, I see file. What you're going to do is do a new file. So you find idle menu on the top, either on the top of this window here, if you're in Windows, I think, or on the top of the screen, if you're in Mac. You're going to see idle, you're going to see file, and you click on new file, and you see a second window opens up. This is going to be your editor. And this is where you're going to be typing your program. Okay, so you can type along with me. Again, the big difference between these two programs, these two windows, again, pay attention, is that this one doesn't have these 3 arrows in the next. These 3 arrows are telling you this is Python shell, where I can type in directly command and execute them by pressing enter. This one here doesn't have a 3 arrow, it's just a place for writing plain text. You can write anything, right? So this is where you're going to write your program, you're going to save your program, and you're going to run it. So let's write our first program, and it's tradition and we're going to stick to the tradition, which is to write your first program that says hello world. Okay, so what we want to write a program such that when I click run, it prints hello world. Okay, so Python has incredibly simple and wonderful syntax, such that in some ways you may even be able to guess, if you know a little bit, how to have a program that writes hello world. So the command is very intuitive. It is print. Okay, so that is a command, or in Python, all of these are functions. And then you open parentheses and close the parentheses. So that's a syntax. That's how you want to ask a Python program to print something. But of course, you need to tell it, what do I want it to print? So that the text that you want printed, you're going to put inside of parentheses between 2 pairs of quotes. Okay, so let's say we said we want to do hello world. Okay, so we put the text that we want printed inside of the parentheses between the quote, and that's it. This is a program. It's a trivial program, but it is a Python program. So what we want to do is run it. So how do you run this program such that then it actually prints hello world somewhere? And where is it going to print? As I mentioned already, there are 2 windows. The one where your editor, where you're going to be typing your text, is this one here. And the results will be displayed here on the shell. It's on the shell that you should see hello world once we run our program. But first, how do you run a program? Again, it's important to understand the difference between these 2 windows, because your cursor has to actively be on this one, on the editor, if you want to run this program. Because look, if my cursor is on the shell, nothing on the top says, in the menu of idle, there is no run button. But look at the change when my cursor is actually, when the active window is the editor, then on top of the screen on idle, you will see an option to run a program, run this program. Okay, so let me go put this down so you hopefully see this better. All right, so now the cursor is on this editor on my program. I didn't want to make this. And I go to run. And what you want to do is you want to click on run module. Don't ask me again why run module rather than just run. Again, module is just another fancy word. It just means run program. Run this program that you just wrote. Okay, you click on it, but then you're going to get your first kind of error. Python doesn't allow you to run a program before saving the file, before saving your program. Okay, so then you say source. Again, fancy word. Source just means a program, yet another word for a program. It means save your program. Okay, you're going to say yes. And it's going to offer me to save a program. You give it some name. I'm going to give it name, I don't know, tutorial. But then you have to put a dot, and every Python program, you should save it with extension py. That allows your operating system to know that the content of that file is a Python program. So you give it any name, then you put dot, then py to indicate that it's a Python program. So I'm going to save this file. And after saving it, it ran it already. Okay, so because remember, first I click run. So let's try this again. I make this window active, the one where my first program is, the editor. I go to run, I click on run module, and it prints hello world again. Okay, so you may decide, oh, let me try to add something else here. Let's see. This is my first Python class. Again, you save it. If I try to run it, I'm going to get the same mistake. So I'm not going to be showing you this. It's very helpful to use it to learn a key combination to save your file, because you're going to be saving it all the time, because you're not going to be otherwise able to run it. So here on the file and under save, you can see at least in Mag that it's POM-S. So, you know, before running it, I did POM-S. So now it's saved. I can press run, and now here on Python shell, as promised, the result is displayed, and our program says, our program displayed, hello world is my first Python class. Okay, so there it is. Here's our first Python program. Okay, so in the first part that we just learned, what is important to know, that to install Python from python.org, to open idle, what is going to do, clicking on idle is going to open actually Python shell, which is this window where in every line you have these three arrows that indicate, okay, that indicate that you're in Python shell, where the results are displayed and where you can run command directly, and that you have a different type of window that you open by clicking either open a new file, where you actually type your program, save your program, and then can run your program. Okay, so for the rest of the class, we're not going to really be just typing code like that. What we're going to be, I mean, we will, but we're going to use, in order to make it a little bit different or a little bit hopefully more interesting, is what we're going to be doing is we're going to be trying to draw pictures with Python. Okay, draw figures with Python, in particular some geometric figures with Python. So that's what we're going to do. And for that, we're going to use a Python package that somebody developed. It's called a turtle package. That's going to allow us to, you know, draw. There's a third window that opens where you're going to be able to draw something. So we can do that together. And I'm going to be asking you, oh, so now draw something else and stuff like that. Okay. So before we move on to that, let me see if there are any questions. So it says, I'm in Windows, I just installed Python, and I can't have the menu for idle. I'm not sure what that means. Does it mean that you cannot find idle? And again, I don't know, maybe other students can help you. How do you find newly installed software in Windows? Surely there's some search button, or you go to applications and find idle. And then once you click on it, there will be, so in Windows at least, if you open something, the menu is either on the top of the window, right here on the top of the window, and maybe it's on the top of your screen, like in Mac. Again, I'm sorry, I really don't know. I have never had a Windows machine, so maybe some students know how to answer your question, which is, where's the menu, I think, of idle. Okay, so let's now try to draw something. So as I mentioned, we will use a package called Turtle, and it doesn't even matter what that means, a package, but somebody made a little program that allows us to draw things in Python. And that package is called Turtle. So first of all, we want to make sure that we have access to those commands. And the way you do that is you type import Turtle. So on the top of this file, on top of our program, you should type import Turtle, okay? Just so we can use the commands for drawing things. And in order to draw something, typically figures are drawn on another screen. So what we want to do first is create a little screen where we're going to draw the figures. Okay, so somebody raised a hand. So go ahead, you can try to speak if you can. Okay, wonderful. So here, the person who couldn't find how to run idle, in Windows, they just typed idle in my starting menu. Yes, don't type Python. That's what I was saying. Type idle. You type idle in your start menu in the Windows and you press enter and you should start idle. You should find this. Another person asked is, does Python only work on computers or it can function in iPads and iPhones? Again, I really wouldn't recommend that that's what you use for university. You can, because you can find everything web browser based, right? You can go on a web browser and find somewhere where you can type Python program and press enter, but you may start having issues. So I really recommend you that all of you that you have a computer, but you don't have to have a computer. There are labs. There's a 24-hour lab in the engineering building, in a side building. There's a big lab with computers. Lab is open 24 hours. All the students have access there, so you don't have to buy a computer. And again, you can make some things work on iPad or any type of these tablets running Android, but mostly web-based, or you find some apps for it. But you know, in a sense, you may end up in a situation that something is not working. Maybe you're going to be fine, maybe not. Don't know. Okay. All right. So let's try to draw something. Import Turtle. That's the first line. So by the way, you cannot invent these commands, right? I mean, hopefully by now you understand that not everything that looks like English is going to work, right? Even the first thing, if I did print hello and I didn't put parentheses or I use capital print, even the programming languages are case sensitive. So you really have to, with time, you're going to learn the commands. And this is not going to work. You invented, I'm going to use a capital P. That's not going to work. So you really have to know commands. Every time you're going to learn them. Don't worry about that. The course is not about memorizing commands. All right, so import Turtle. That's the first line. So we want to now create first a window that is going to, where we're going to be drawing things. Okay, so you need to have a command or a function, Python function where window pops up, where our drawing is going to show up. That command or that function, you don't know it, but I know it, so just type what I typed. You should type turtle dot, I don't even know it myself. I had to look it up, and I'll show you where you can look up all sorts of functions, all sorts of things that you can draw with Turtle. Okay, so here's a function called screen. You open parentheses, so you do turtle.screen. You don't miss an R like I did. Turtle.screen, open parentheses, close parentheses. So this is a command that creates a drawing window. Okay, and I want to have access to that window. I mean, I want to give it a name, and this is basically a variable, but let's not go into that. I'm going to call this window WN. Okay, so I save this file and I'm going to run it immediately. And this is another lecture, especially for those who have never programmed before. You write one line of code and run it to see whether what you did is working. Then you move on. So let's see if this creates a window. If I run this module, you see a window. This one here, Python Turtle Graphics. That's where we're going to be drawing things. Pops up. Okay, so that part is working. So I'm going to shut down this window. But in fact, I'm going to also create, have another command. Oh, there it is. I'm going to copy paste this. Okay, no. So, all right. So all my code, I'm going to type within. And in fact, this idle gives you nice gives you actually suggestions of what might be the commands that you want to use. And here I really want exit on click. That's the command. I'm going to tell you what that does. Why is it stuck? I have a little issue with my keyboard or something. Oh, there it is. Just a moment. Exit on click. So what this one does, so this command here creates a window, drawing window that we call WN. And this one says that window, if a person is done and just clicks on the window, shut it down. So let's try to see if that is working. This is not important, really. We are not drawing anything yet. So the window is open and any click shuts it down. Okay, when we looked at the drawing already and we are done, we click on the window and shuts it down. Okay. All right, so let's now draw something. So this drawing, the way they start normally, you take a pen and put a pen on a paper and draw something. And in this, how do you say, this Python version of that, what you need to do is you create a turtle on that screen. And it's turtle walking around the screen that is going to simulate your pen. I don't know why they call it turtle. It's probably meant for much younger programmers than you guys to make it less boring. Okay, so let's create a turtle, which is equivalent to saying, let's create a pen on that screen. And then when we move the pen, it should draw something. Okay, so the command for creating a turtle, in your head, think of it putting a pen on a paper, is again, you start with turtle. So basically you're telling Python, I want to call a command from turtle module. And the command for creating it is capital turtle. So lowercase turtle dot, and the command for creating turtle is capital turtle. And then as all the functions, you will see this as we program in this semester, as all the functions in Python, you open parentheses, close parentheses. Sometimes you're going to put something inside of these parentheses like we did in print. Sometimes you're going to put nothing like we did in this turtle here. And then you want to give a name to turtle. Let's say I call it Anna. Okay, you can call anything. So this here is just a variable that gives you access to that turtle. Is what you name your object. In this case, this turtle. Okay. All right, so let's try to run this and to see if anything changed. All right, so we click run. And as you can see, we still get this window, but in the middle of the window, we have an arrow. That's our turtle, that's your pencil. So now if you move it forward, you should draw a straight line, for example. Okay, so what these 3 lines of, and now when I click on a window, I'm done, it's shut down. So what these 3 lines of code do, the first one creates the screen. The second one puts in the middle of that screen, it puts an arrow, which they call a turtle, it's just like a pen. And then a third command, when you're done looking at your picture, you can click on the screen and it shuts it down, your drawing screen. Okay, so now we created this pencil or this turtle called Anna, and I want to make it move and leave some light. So you can see that by doing something with this pencil or with this turtle, that it can draw things. Again, a command I'm going to use, I know it, and then I'm going to show you where you can see all the possible commands you can do in this module turtle. You should use command or function, more precisely called forward. And then again, open parentheses, close parentheses. In this case, inside of this, if you want an object, in this case, a pencil or a turtle, to move forward, you should tell it by how much, right? I mean, it's logical that you should give it some units, some measure. So I can say, okay, move forward by however many 100 of something, 100 pixels maybe. We're on the screen, so maybe you're basically saying move forward by 100 pixels. Let's see if that works. So I saved it, I go on the top, I run it, and you see that happened. It started over here and moved by 100, and then it stopped. Okay, so what we have here maybe I can increase it to 200 such that you see, or 300 such that you see that it really goes forward by different measure, and this was a 300. Okay. And now let's try to do, what else can it do? Or maybe I can tell it, oh, turn left. Okay, so I can tell, okay, Anna, my pencil, why don't you turn left? I don't know, by 90 degrees. You know, when you telling somebody turn, you know, maybe you should tell them by how much. So this way, that's why inside of parentheses, I'm giving an angle. I say turn left by, so that arrow now that was pointing to the right, when I say turn left by 90 degrees should be pointed top. And then I say, okay, move again by 100 units, by 100 pixels. Okay, so let's see what happens now, and you see indeed it did that, right? So arrow was pointing to the right, it moved forward by 100, then it turned by 90 degrees and went up by 100. Okay, so now you, looking at this code here that we did, so here's what this code did. So these 3 lines, okay, we already created a turtle. So these 3 lines of code, forward, turn, forward, drew this figure. So why don't you all take a minute or 2, however many minutes you need, to complete this into a square. Square is just, you know, a polygon where all the sides have exactly it's a rectangle with the size of exactly the same length. Okay, so why don't you all complete that? I'll give you a minute. So there's a question of what is the importance of parentheses at the end. That's a very good question. It's basically a syntax. By syntax, think of it as a rule. So in some time, when you give somebody a command, it's clear without any extra information. So what would be example of that? Maybe, let's say to humans, you say sit down. They're standing in front of the chair. You say sit down. You don't need to give them any further information. Okay, they sit down. But if you tell somebody move forward, well, they kind of, or you know, they kind of need extra information. By how much do you want me? You know, go straight. If you're giving instruction to somebody, you say go straight, but then you should tell them how much. You know, you should say go straight, and then they need extra information. Let's say 100 meters. So all the functions, or rather commands, if you want more colloquial language, all functions in Python, and you will see this throughout the semester, will have a syntax, which is name of a function. So that means, what does the function do? Print, forward. Then you're always going to have parentheses. If they are empty, that means there is no, inside of parentheses, if you don't put anything, that means it's the extra information is not needed. If for this command, extra information is needed, like this, left, if I say turn left, I should give you an angle. Is it by 90 degrees, 45 degrees? Move forward, I should give you how many pixels to move forward to. Then you will be adding extra information inside of these parentheses when the function needs extra information. So hopefully that answers your question. I'm going to have some water, and again, I hope, I clicked on that window, and remember, clicking on the window shuts it down. Okay, so I'm gonna have, so you complete this to a square. And I will, let me just check something, give me a moment. Okay, so hopefully you all figure out how to do this. So in this moment, the arrow is pointing up, but we actually want it to turn and go forward. So we need another left turn. and then move forward. And then we need, so that would mean we are over here, top left corner. So we need move, turn left again. And then move forward. And then at the end, if in the center we want, then the arrow would be pointing down when we completed it. But if we want to put arrow back the way it's all started, we make another 90-degree turn and let it sit there. So let's see if that worked. All right. So we have completed that. So this piece of code here draws a square where the side length is 100, whatever, I think 100 pixels. Okay, you know, you can change that. Maybe I want a bigger square, a bigger size, and size 200, and now we created a bigger, now we created a bigger square. Okay, so our next thing is, okay, we know how to draw a square. So before I look at your questions, we say, okay, we know how to draw a square. What about, so square is just a polygon, a convex polygon, or basically four-gon. It's a polygon with 4 equal sides. Okay, so non-crossing polygon with 4 equal sides. So it's called four-gon. Okay, what about if we want to do octagon? So instead of a square, I want a polygon with 8 equal sides. It's called octagon. Okay, so how would we change? So something for you to think about is how would you change this code such that we, instead of drawing square, we draw octagon. Okay, but before we get into that, I'm going to make a pause and look at your questions. And then I'm going to ask you a question even before we go look at how do you draw octagon and then how do you do something more general. You can be looking at this code and you can answer for yourself, or you can answer to me, is something bothering you about this code when you just look at it. In the meantime, I'm going to look at the questions. Do we have to memorize functions, variable, any other during programming? What to focus actually to be comfortable? Okay, I'm not, Omar is asking to repeat something. I'm not sure what to repeat. But this is a very good question. My goal never, ever is that you memorize anything. So throughout the course, you will be programming a lot. If you ask anybody who is good at programming, you have to program a lot. It's not possible to become good at this without making lots of programs, without solving lots of problems in programming, okay? So in this process, for example, you're going to see this print function million times. Well, million, I'm exaggerating, but you're going to see it so many times that you're going to remember it without any effort. So they will be commands. I may tell you, you're going to, in fact, before midterm and before the final, I make a list of functions and tell you which functions you're going to see in your exam. It's not my goal that I somehow surprise you and you don't know what the function does, you know, so don't worry about that at all. There will be functions that you're going to be repeatedly seeing in the labs, in the class. So there's no way that you're not going to know them. So don't worry about that. The goal of the course is to develop computational thinking, to figure out how to solve computational problems. So maybe I'm saying this and this doesn't make any sense. And actually, I assume it doesn't make any sense. What does it mean to solve a computational problem? So in this, and indeed, in this little tutorial, I will take a little break to give you an example of what that means. And this is the reason, solving computational problems, this is why you're at the university. You can learn the syntax of programming language yourself. What is difficult is solving a problem. So what you want to be able to do is to develop a skill of solving a problem. And once you do, whether you're going to be translating in your head, whether you're translating that conceptual solution, which is called an algorithm, a procedure, whether your solution, which is an algorithm, whether you're going to be translating it in Python or whether you're going to be writing it in Java. So basically, what programming is you are translating your conceptual solution, your algorithm, procedure for solving a problem. You are translating it to something that computer understands. They understand Python, they understand Java, they understand C, and all of these languages. So what you're going to be studying through these 4 years or developing through these 4 years at University of 5, depending what program you're in, is going to be, you're going to develop your skills for solving problems, computational problems, for developing algorithms in various areas. Okay. All right, so hopefully that answers your question. Okay, Omar, so this is all recorded, so you can go back at home at the end. I don't want to repeat again the same thing. I spent quite a bit of time explaining what these parentheses mean. You always, after the name of the function, you need to put parentheses. Sometimes there is nothing inside of parentheses, means no extra information is needed by the function, by the command. Sometimes you need to put something in parentheses, which in this case, in case of forward function, it's a number that tells you how much forward you should go. In terms of left function, it's a angle by which you need to go by left and right. But in general, this is recorded, so you can revisit my original explanation, which was longer, if you wish. Okay, but this reminds me, so I wish I knew how to dismiss this. This reminds me, at this point, again, so hopefully you're thinking what bothers you about this program, but you may be asking, okay, how did you know about how to create a screen? What are these commands? What are these functions? Okay. How do you know that there's a forward, that there is left, and that there is a screen for creating a screen? So Python is actually really great for that. In other programming languages like Java and C, you would have to find the documentation if you're looking for some functions. But Python, actually, when you install Python, there is a place where you can ask what commands do you have, and you actually have help pages on those commands. So let's take a little brief moment so I can show you where you can find those, what commands are available, what function, they're called functions in Python, what functions are available. So I'm gonna click on this window to shut it down. So remember, this was our program. This is a program, it has no triple arrows, but you need to go back to the shell, which is where these triple arrows are. So let's go back to the shell. If in your case, you can't find the shell, the easiest way to make shell appear again is to run a program. So if you run module, it's gonna draw the thing. You kill the drawing, but the shell is there. You can also find it in the menu here. So if we are in our program, you can run here, Python shell. You can go in the run and Python shell is going to open. Okay. So we are in this turtle module, and I want to see what is everything that is available in this turtle module or package. Okay, these are the same words. Okay, so you go to the shell and the command or a function is dir. This is a very helpful function. Again, so dir is a function that lists all the commands of a package that you're interested in, or module that you're interested in. We are interested in turtle modules, so you tell Python, inside of the parentheses, you put the name of the module for which you're interested in all the functions that are there, all the commands that are there. You press enter, and here's a list of all the functions, all the things that you can do with the turtle. You should ignore all of these at the beginning that start with underscore, and here it is. So it is this. All of these are commands or functions that you can use in this turtle module. So you should be able to find forward that we used already. You should be able to find left that we used already. So for example, here's a forward. But some of these, what is on timer, you don't know what they're doing. So in addition, dir lists all the functions that are there, But in addition, you may want to know each of these functions, what they're doing. For that, there's another function called help. So for example, so these are the functions that are there. But now I can say, oh, help, tell me what turtle dot left or turtle dot forward does. So we do turtle dot help, turtle dot forward. Okay, so I do help is another function. You open parentheses, close parentheses, and inside you ask help on what function. Okay, I want to know what turtle dot forward does. And I press enter, and it explains that function forward moves the turtle forward by a specific distance, which is what I told you. Okay, so you can go through these and learn by yourself. Learn by yourself what they do. For example, there is something here called color. And that one, let's see what color that we can probably guess. Turtle dot color. That one changes the color of the turtle. I mean, you've seen that the color or the other color of the pen, that by default it's black. But this one is, you may use a different color for that pen. Okay, so again, function dir, and then inside you put the module name. In our case, is turtle is going to give you all these functions that are available. A list of modules, that's a good question. Where can we find a list of modules? That is a good question. I'm actually not sure I know. I don't think empty one does that. No, I'm not sure. I know there's a math module that you're going to be using, so it has extra math functions like, I don't know, square roots and things like that. So there's a number of built-in modules. So math is a built-in module. As you can see, turtle is even a built-in module. But there's some module that you have to install if you want to, do something. Somebody, you yourself can develop a module. So you can use, it can turn out that somebody developed a module that you're interested in, and then you can use it. Yes, Lena. If you're trying to speak, you should unmute yourself. We cannot hear you. Or otherwise, just type your question.
Go ahead, Lana, try to unmute.
You're muted.
Oh, okay. Can you hear me?
Okay, yes, Lena, you can speak. Go ahead.
When you write forward, you have to add a specific distance, but if you add a negative number, what it means is like it will go backwards?
Okay, so that's a very good question. All of these things, so the students often during the class ask me this thing, but just do it, right? We can do it together. I'm just saying this is great that you're asking. This is one of the best way to play, to learn, especially initially, is you have a question like this. Oh, what happens if I do this? Well, just do it, right? So let's figure out if I did here, minus 20. Now it's not going to draw a rectangle because we messed things up. But let's see if it's going to go backwards, right? It did go backwards, right? It's not drawing any more rectangle. The call is different, but it does go backwards. So that was a good question, right? Okay. So, all right. So let's go back. So if I remove this minus 200, we are back and drawing rectangle. So let's go back to my question. Is anything bothering you about this code? Anybody? Anything bothering you about this code? Yes, one S.
Yes.
Unmute yourself.
Can you hear me?
Yes, go ahead.
You might have mentioned it already, but sorry if I missed it. It's just that it says forward 200 and left 90. Is that the distance? If so, how come one is shorter than the other if it's a square?
No, so forward is distance. You go forward by 200. Left is an angle. Now turn by 90 degrees. So you move forward 200, then turn by 90 degrees, then move forward by 200, then turn 90 degrees, then move forward 200, then turn 90 degrees, and you go back to where you started.
Okay, sorry, I missed that. Thank you so much.
Okay, no problem. Please mute yourself, guys, when you finish. Okay, yes, too repetitive. So the answer is in the, as you can see in the chat, this code is too repetitive. We wrote 4 times, we wrote the same code. And this is something computers are great at. Instead of writing this, we should just say, repeat 4 times this, right? We should tell, instead of writing code. So the way I wrote it right here, me, a programmer, I typed it 4 times rather than typing it once and then tell Python, do it 4 times. So there is a function or command, a way to do this in all programming languages. It's called a loop. So you want a loop, you want to repeat something 4 times. So here's how you do this in Python. So I don't want to, because notice these 2 lines are the same as these 2 lines, are the same as these 2 lines. So what we're having a 2 lines of code repeated 4 times. So instead of writing it like this, I might as well just tell Python, repeat these 2 lines of code 4 times. Okay, so here's a syntax for that. Syntax means here's how you do it. Okay, in Python, every language has a way to do this. So here's how you do it in Python. You know, this is one of, I mean, there was a question, would I have to memorize? Well, in a sense, you will have to memorize this because you're going to be doing this all semester, but then it's not memorizing. So here's a sentence that you use a word, special word called for. These are called for loops. Then you put a variable name. Variable is something that you can name yourself. We're going to figure out what this variable does. But for now, just, you know, remember it. I have to put a for, keyword for. Then I have that I cannot invent. Then some name for a variable. And typically you call it I. You give this variable name I. Then you have to put a function called range. Then you open parentheses, close parentheses. Then you put a colon. That's a syntax, main syntax. Inside of these parentheses, this is where you put how many times you want to repeat something. So we want to repeat 4 times these lines of code. Okay, so that's the syntax. For, then variable name. In our case, I'm going to call it I. Oh, sorry, I'm missing one. Then another keyword in. For variable name in, then the range function, you open parentheses, inside of the parentheses, you put how many times you want something repeated. Okay, we want to repeat these 2 lines of code 4 times. That's why we put a 4 there. But now the question is, how does Python know what do you want repeated 4 times? Maybe you want all of this repeated 4 times. Maybe I want to have here print goodbye when we are done drawing this. So what do you want to repeat 4 times? This 1 line, all 3 of these lines? Well, you as a programmer have to decide what you want repeated. And what we want to repeat is these 2 lines. But how does Python know what you want to repeat? In other programming languages, you would put here curly braces. You would open curly brace. What you want repeated, you put between the pairs of curly braces. That's what you're going to see in Java next semester, that you're going to see in C. In Python, it's even simpler in terms of readability as well. You don't need to have any braces or special things. All you have to do is indent in the code that you want repeated. So here's what that means. Okay. Here, that's what it means. So Python, when it encounters command like this, so far, by the way, let's go back. So far, all the functions, all the commands we wrote were lined up with the leftmost edge of this editor. We're right against the leftmost edge. Okay, that means something to Python. But now, if you want something repeated inside of what is called a loop, if you want something repeated, in our case, 4 times, Python is going to know what you want, because all the commands that you want repeated 4 times, you put them in. Okay, so Python now knows, oh, this one is, this print is not indented in, so this is not part of the loop. It's outside of the loop. So it's these commands here that are indented in that I want repeated, so they're part of the loop. This is called the loop, the thing that you want to repeat. But you may wonder, okay, but what is important here is the spacing. It's important that it's the same. This is not going to work. it's indented in, you may decide, oh, I'm going to just make 3 spaces, 1, 2, 3, but then this one also has to be 1, 2, 3, 1, 2, 3. Okay, that's going to work. But if I do this, the spacing is not the same. It's not gonna, you're gonna get one very frustrating error. It's called unexpected indent. Python doesn't know what you want. The indenting has to be the same for the things that you want repeated. Okay, so in fact, these editors are clever enough that if you just press enter, it's going to have a suggested spacing, which is a tab, that you just use the tab line. So you can use any spacing you want as long as it is the same for each command that you want part of the loop. Okay, so let's see if this worked. Run module, we created a rectangle. So the code really works. The program repeated what you told it to be, these 2 lines of code that you want repeated. Okay, so now let me run it again, just because I want to go back to the question that I told you to think about at the very beginning of this tutorial. Not very beginning, but you know, there has been at least 15 minutes, but we learn hopefully some new things. So this code here, this code, okay, so exactly this. Okay, so this thing here that I highlighted in gray is a code that draws a square. Okay, so now let's go back to the question I asked maybe 15 minutes ago. How would you change this code to draw octagon? Okay, so such that we all agree on what I mean by octagon. Right, so just a moment, I'm going to, all right, so let's agree on all what I mean. So here's a square. It has 4 corners. Octagon has 1, 2, 3, 4, 5, 6, 7, 8. I'm not doing the best job, but hopefully you know what I mean. That's an octagon. Okay, so that's what we want to draw. You know, the same as square, but 8 equal sides. So if we go and analyze this code, what it does what it does in case of a square. So let's see what this code does in case of square, so we can figure out how to modify to draw octagon. So this code here, what it does, that's the code. Okay, so what it does is, you know, that our turtle, it was black, so let me use, our turtle wakes up somewhere in the middle of the screen, and then it's told move forward by 200, so it moves forward by 200, so it draws that side. Okay, so it draws that side, and then it says turn by 90 degrees. So basically, what we have here is that our turtle is moving in this direction, and then it turns by 90 degrees. Okay, it turns 90 degrees, then it goes forward again by 200 units. Then it again moves by 90 degrees, and then it moves forward. Then it turns 90 degrees, and then it moves forward, and that's how it draws a rectangle. So to draw this guy here, okay, we're going to try to do the same. We wake up somewhere, that is our initial position. We're going to move forward, not 200 or less. And what we have to figure out now, what is different? First of all, what's different is that we have 8 sides. We have to do 8 times forward turn, because we have 8 sides. So that part is easy, right? So we put 8 there. We have to go forward, turn, 8 times. All right, so that part is easy. But this angle here, just a second. Was it? No, is that right? Yes, yes, coming. As I mentioned, the internet is not working, so there's a technical person here. I'm on the phone internet. There's a technical person here. They're going to check home internet. So that was the interruption. But let's continue. So in this case, in the case of a rectangle, we were turning 90 degrees. And here we have to figure out what is this turning angle? What is this angle here? So we have to do this 8 times, but the turning angle obviously is not 90 degrees anymore. We're not going to get an octagon. Okay, so we can still use the length of the side 200, so we don't have to change that. What we have to change is this angle here. Okay, so I'm assuming I have 8 messages in a chat. I'm going to open them now that some of you know what this angle should be if we want to draw octagon. All right, so already, exactly. So the first person said we should change 90 degrees to 45 degrees and repeat 8 times. Okay, so all of you. Okay, very good. All right, so very good. Everybody did this. I mean, not everybody. So let me remove this. Very good. And let's see that these suggestions work. So 30, it's not 30. For some other examples, it may be 30, but we're going to get to that. Okay. All right, so we were told 45. Let's see if that's working. Run module. There you go. It's too big. The side is too big. But indeed, it drew octagon, and we can make sure that we see it by picking a little bit of smaller side. That let's do 70. Let's see if that is going to fit in the screen. So let's run it. Okay, there you go. We drew octagon. So this code here draws octagon. Okay. So as you may guess what my next question is. So we know how to draw square, which is a 4-gon. We know how to do octagon, which is an 8-gon. What about 10-gon? What about 15-gon? So one of the things that you want in computational problems is that they are able to solve any version of the same problem you give it. Not just we are drawing an n-gon and you can only do it for n is 4 and n is 8. Okay, so in general, what you would like is that you ask a user, somebody's using this impressive software of yours, and you ask it, how many sides do you want your polygon to have? You capture the answer. Let's say they say 11, okay? And then you want to draw 11-gon. So, you know, convex polygon where all the sides are the same and that there is 11 sides. Okay, so that's going to be our goal now. So you could guess what we're trying to do. So in my explanation, one of the things that you may have heard that you would like to have a program that asks user, how many sides do you want, right? It's not me hard coding, deciding, oh, it's 8, or it's not like programmer deciding how many sides. It's whoever is using your program, you want them to tell you how many sides. So that implies that there should be a way in Python for us to ask the question to the user. In fact, we know how to do it. I can use a print. I can use a print statement, say, how many sides do you want? But then I need a way to capture the answer, right? So we should be able to ask a question and capture the answer, and then use that answer. In our case, how many sides? I want that answer. So maybe they said 11. I want to be able to capture that answer and use that information to draw the pentagon, to draw n-gon that I want. So the next thing that we're going to do, and that you can actually do all the semester, is, you know, how do you ask for a question and capture the answer? And in Python, it's particularly simple. Okay, it's really simple. So you're asking a user for an input. So you can actually, the command is called input, the one that allows you to ask a question and capture the answer. In fact, it allows you to do that with one function, with one command. Okay, so let's do that. So instead of, again, here, hard coding the number of sides you want, I'm going to ask the user how many sides you want. So after creating a turtle, or maybe actually even before, we're going to ask a user, you're going to use a function called input. Okay, so this one here, again, it's a function. So you're going to open parentheses, close parentheses. Inside of the parentheses, you're going to pose your question. Okay, the question is, how many sides should the polygon have? Something like that. Oh, and then we close, just like in print, all these text that you want to display, the text that you want to display, you should put it between a pair of quotes. Those are called, the text with those quotes are called strings in Python and actually in other languages. So this input function, you give it a string. So you give it a text between the quotes. You want a text that's going to be displayed. And then this function, then the user is going to type an answer. Let's say 11 is my example. And then this function is going to return to your program that number. Okay, whatever user inputs is going to return it to you. But you want to capture it. And, you know, because you want to use that value, you capture things in variables. So what you're going to do is you're going to say, whatever this function returns, you should assign it to a variable. You give a name to the variable. I'm going to call it n. Okay, so n. So this function here is going to ask a user, give me a number of sides. User input something, as I said, example 11. And then this function input is going to return that number, and that number is going to be stored in a variable. The name of the variable is your choice. My choice is n. So n should store the number of sides. Okay, so let's see that that part works. You know, let's leave this code here with 8, but let's see now, are we able to capture this, you know, the answer from the user? Okay, so I save this code, I go on the top, I run, and you see Python shell here opens, and it's asking me how many sides should the polygon have. And you see here cursor is blinking, it's waiting for me to input the answer. And I input, I want 11. Okay, and I press enter. You know, it looks like it still drew 8. I didn't change the rest of my code. N contains 11. So after drawing pentagon, we have that print goodbye. I'm going to remove that. We don't need that. Okay, so our program is finished. But our program just ran. And one of the nice things about this shell is that until you run a program next, or until you change something inside of this shell, you can look at the variables of your programs, what's inside of them. So if I put n here, remember n is the name of my variable. If I go to shell and put n, it tells me that n is 11. So I just did n and press enter. And then remember, this is, if you're in the shell, which you recognize by looking at these 3 arrows, you are going, it's like your window into Python. You just ran that program, that variable is still there, and you can ask, what is the value of n? And you can press enter, and it shows you it's 11. Okay, except pay attention to what it looks like. It's 11 under the quotes. So it's like a text, right? It's not a number. Why am I emphasizing this is because we actually want a number. What's the difference between a text and it's like a textual 11 versus real 11 integer? When you have a real number, let's say I have an 11 times 2, that then you can do mathematical operation if it's like that. I can do 11 times, 2.5 and things like that. Or 0.25 in case this, but this n is a text. the importance of realizing that it's a text, that it's a string and not a number, is that then I cannot do mathematical operation. I cannot multiply it with 2.5. I'm going to get a crash. So this function, why am I telling you this? There are technicalities of programming languages. You should know what your functions return. So this function input is always going to return to you what the user inputted, but it's going to return it to you as a text, as text. So if you want a number, in this particular case, we actually not want a number, we want an integer. You should convert it into integer. And there is a way to do this. You just put int, you see here, int. So whatever this function return, so here you put, so you have that whole command, you put it, so whatever this function returns, you give it to this int. So here's the command. Int is a function that returns, that's going to try to make integer from your text. If your text looks like an integer. So you have here a command, and you put it inside. The command is going to return text 11, and this function int is going to actually make it into a real integer. So let's see if that actually worked now. Oh, I have a little crash. Sometimes that happens. Okay. All right, so let's try that again. Oh, it wasn't turtle, it was tutorial. Okay. So here's the code. I'm gonna comment. By the way, if you don't want some lines of your code to be executed, you just put a hash in front of them. So let's do that now. So this is asking how many sides does your polygon have? It's 11. Okay, I made a mistake somewhere here again. Ah, it's this window. Okay. Just a moment, Lena. 11. Okay, I did 1, doesn't matter. So now if you look at what's in this variable, and it's not under quotes anymore, it's an actual number such that, and that means you can now apply mathematical operations to them. Okay, this was just to teach you on the side about input function, because you will be using input function in your upcoming semester all the time. Okay, so now we learned how to get input from the user. So instead of drawing 8 gone, we want to be drawing n gone, whatever user gave us. If they gave us 11, we want to draw 11 gone. If they gave us 30, we want to draw 30 gone. So we need to change this code such that it draws an n gone for any n the user gives us. Okay, so while you think about how we should change this code to achieve that, I'm going to look at your messages. I haven't done that for a while. And there was a hand raised by Lena. You can ask your question, Lena, while I'm looking at the messages. Okay, so some of these are answers about the previous question about NGON. Yeah, so I would like you, if you know the answer, not to type in, so ahead of for to being too fast for the students. So we're gonna all try to develop this solution together. So if you have, no, don't worry about that. Just so it's good that you know how to change it, but let's do this together such that everybody. So here's a good question: how you draw a circle? I like that you asked that. We're gonna get to that. Actually, first of all, you already can. Look at the dir function. Remember, dir tells you how to all the functions that are available. You're going to find a circle function there. So you can always just do n dot circle, and it's going to draw a circle. But, you know, maybe I give you a say, oh, how would you draw a circle? And you're not allowed to use a circle function. You're going to see it in some of my assignments, because sometimes I want you to learn something, to a specific skill. And then that skill is trivially, you know, not even skill, that task is trivially achieved by some pre-made Python function. So then I'm going to say, you're not allowed to use that. I want you to solve this function. I want you to solve this problem without using this and that. And the goal, again, is to, for you, if you don't know how to do it without it, that already means you're missing some knowledge. There is my goal is to make you think and make you solve something. Okay, but we're going to get to the circle.
I have
I'm
Lana
glad
here.
Yes, hi, Lina. Go ahead.
I have a question. So I've been trying to recreate the how many sides should a polygon have, but it doesn't work for me. So it doesn't have that question when you go on idle shell. It says how many sides should a polygon have. It doesn't like give me that question, and it doesn't work for me.
Okay, so this is very difficult without me looking at your screen, but one of the things that you have to make sure is that you went to the shell, that you really switch the windows, that you find that when you say hit run, that your shell is not hidden by the screen. So one thing you should try to do is to remove all of this code, all of this. You remove it and just leave this. We go back to the basics when I said you write one line of code and make sure it's working. In this case, have just this. Forget even import turtle you can remove. So this should work as one line of code. And then you should be able then it should work, because you will see only two windows, the one where you're typing your code and the other one is shell where this question should be displayed. Okay.
Thank you.
In fact, this is one of the reasons you guys will have a lab, because in the lab, there will be a TA that is present there in person that can look at your screen and help you with some things you're struggling, right? Otherwise, everybody can program on your home. But one really big plus of the labs is, first of all, you're going to get exercises to program. So otherwise, how do you know what you should really program and which direction to go to? And plus, the TAs are there to help you with things like this, that right now is difficult for me without you sharing the screen to figure out why you don't see it. Okay. Okay, so let's see how we do this. So this part is easy, all right? We should draw n sides, okay? This is just the length of the side. We can pick any length of the side that we want, so that doesn't change. What we really need to figure out, and some of you, as I can see in the chat, some of you know the answer, is what is the angle for any n, right? So you don't know n ahead of time, you just know that, you know, that number of sides is stored in variable n, and then how do you compute the turning angle? What is that turning angle? Okay, so let's try to figure that out. All right, I'm gonna take a little break to, no, not really a little break, just give me a minute, I need some water. While you guys think about. Okay, so. Okay, so let's look at, so here's already a very small example of something that what we are stuck in, if you are stuck. Some of you know how to answer this, but I'm guessing some of you don't, right? What do we do now? So this draws an n gone. You know, we can leave 45 degrees, but I have an n here. What if I put, you know, 11, I press enter, it's drawing something, but it's not in 11 gone. It's just going around drawing things 11 times, right? So it's not doing, this one has 1, 2, this is still 8 gone, right? Even though I put n here, even though this is repeated 11 times, these commands, it's just going around on top of itself. So you really need to figure out what this angle is. So again, some of you know how to do it. So it's not about the code. It's not about not knowing Python. You know the Python. What you don't know is what is this angle in terms of n? Okay, so this is really small example of something where you need to solve a problem or be able to solve a problem at hand, rather that it's about programming or that it's about programming language. Of course, this example is so trivial that even if you don't know it, you can Google it. You can try to find this on Google and probably eventually you would find the answer to this. But there's two things to consider with this. First of all, when you find something on internet, I mean, all of you are aware that you can find all sorts of wrong, plain, totally wrong things on internet. So first of all, you already need to know something to figure out, is this correct, this information that I found on internet? Second of all, if all of these things that, if you know, somebody hires you to do something, and imagine you can find all the answers on internet, but then why would they hire you, right? So the reason why you want to be valuable, if you can figure things out, right? If you can solve things that haven't been solved, that's why you are being hired, that somebody needs, you need to be able to solve problems that, you know, you cannot just readily find on internet. So let's try to figure out, and even for those of you who knew the answer, ask yourself, do I know why? Why is that the angle? So let's try, just as a small example, let's try to figure out what that angle is. Rather than Googling, what's that angle? Let's try to figure out what it is. Okay, so I'm going to draw a picture that hopefully is going to help us figure that out. All right, so in this most general case, okay. All right, so let's say we are in this general case and, you know, n is some number. I don't know what it is. I'm not really good at drawing this. I don't know what gon is this. I hope it didn't kick me out. It says your session is expired. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8. Oh man. Well, let's do something that we didn't do. All right, I'm gonna draw a bad picture. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's say 7. Really bad 7. So what you need to know, what we need to know is that, you know, we start, let's say we started here and, you know, and we move by 100. What we need to do is figure out what this angle is, the turning angle, when in the case when n is 7, or general n. Okay, so what you really want to know is what is this angle? So, and all of these angles are the same. When you have an angle and all these are the same side, so we need to figure out just that one angle. And, you know, we want to know what is this angle alpha. So the first observation is that, you know, this angle here, alpha, and this angle here, beta. So let's do this one like this. And this internal angle, beta, right? So we have this alpha plus beta is 180 degrees. We know that. So if I know what beta is, I know what alpha is. So alpha is 180 minus beta, because we, you know, we just go straight. That's 180, that's straight. And my turning angle alpha, okay, this turning angle and this internal angle of the polygon, alpha plus beta is 180 degrees. So if we know how to figure out what beta is, we know alpha immediately because it's 180 minus beta. So let's try to figure out, for me at least, it's easier. I have an angle and I want to figure out what is an internal angle based on something that all of you know. The only thing I'm going to use here to show you what that angle is something that you all for sure know. Okay, so I want to figure out what this angle beta is, this angle here. Okay, so the internal angle of the angle. Okay, so this is beta. Okay, first of all, in a regular angle where all the sides are the same, all of these angles are the same. They are all equal, they are all beta. So here's the first question. If I tell you that this is an n-gon, it has n sides, and all of these angles are the same. And if I tell you, oh, I will tell you what is the sum of all of these angles here, all the possible angles. Let's say I tell you sum of all of the beta, I give you that number, it's some big number x. Do you then know what beta is? If I tell you this angle plus this angle plus this angle, I add all of these angles, all of these n angles, I add them up together, they're all the same, I tell you that sum is some number x. Do you then know what is beta? Well, that should be easy. Then beta, if sum of all of these angles is x, then beta is x divided by n. There's n of those angles. Okay, so that means that if I know the sum of all of these angles, we are done. I just divide it by n, I get beta, and then I do 180 minus beta, we find out the turning angle. Okay, so that leaves us with the question, what is this sum? What's the sum of all the angles inside of a regular angle? Okay, so let's figure out if we can figure that out. Okay, so we are looking at this. Here's a fact that all of you know. So this is the only fact that I'm going to use, that if you take any triangle like this, the sum of these three angles is 180 degrees. You all know this, hopefully, right? So we know that in any triangle, sum of all of the angles is 180 degrees. So this plus this angle, no matter what triangle you give me, sum of these angles is 180 degrees. So to figure out what is the sum of all of these angles, I can partition the interior into triangle and just use this fact, use what I know, okay? So let's figure that out. I have an angle. What I can do is divide the interior. I pick one of these corners and take straight segments to all the other corners. All the corners I'm not adjacent to. So this corner already is adjacent to its two neighbors, so I don't add those. But I add the remaining n-1 diagonals. I end up with I add the remaining n-2 because two of them I'm already adjacent to. So this and this. So I add the remaining n-2 diagonals, I end up with n-2 triangles. Okay, so triangle 1, 2. So there is, I should use a different color. Okay, so there is n-2 triangles. And sum of the angles in all of these triangles is 180 degrees. Okay, so if we look, here are the angles. I'm going to finish soon. This looks like a geometry lesson. I just want to make sure that we all see that some of it is about problem solving. So here's the angles in the first triangle, then the angles in the second triangle, then the angles in the third triangle, then the angles in the fourth triangle, then the angles, in this case, in the fifth triangle. And you see that if we sum up the angles of all of these triangles, we're actually summing up the angles of this angle. So that means we have n-2 triangles. Each one of them, the angles inside are 180. So that big X, the sum of all of these angles beta that we were looking for, is this, n-2 times 180, okay? And then we said, oh, if you want to know what beta is, you just divide by n, by the number of angles in angle. So that's n-2 times 180 divided by n. That is equal to n divided by n, that's 1. So we have 180 minus 2 times 180 divided by n. So that's 360 divided by n. So that's beta. Beta is 180 minus, so that's the internal angle here. Remember, that was beta. 180 minus 360 divided by n. But we want this alpha, the outside angle, which is 180 minus beta. So alpha is here, 180 minus this beta, and beta is 180 minus 360 divided by n. This and this cancel, this minus and minus cancel. And we computed that the turning angle is 360 divided by n. Okay, so now we know what to put there. Okay, so now we know what to put inside of that angle. We don't leave it as 48. We put this, what we computed, 360 divided by n, which is the answer that some of the students already knew. So we put 360 divided by n. Let's run it and see if our program works. All right, so actually I'm going to ask this question even before opening the window. And if you notice, I want to space actually after asking the question. The number was glued to the question mark. So I'm going to, now I fix that. So let's run the code. How many sides? It was 11 that I wanted originally. I now press enter. As you can see, it does draw 11 gone. Let's try to run it one more time. Something else. Let's do 27. Now it's getting out of the bound because there's too many sides. So I should pick, actually, if I want this to fit in, I should pick a shorter side, maybe even 30, the length of the side. Okay, so I want 28 gone, and there it is. This is the 28 gone. Okay. I'm sorry, and now there's a construction. So sometimes things really don't go like the best possible way. Okay, so we solved this problem. We know how to draw an end gone for any end the user gives us. But you can now also go back to one of the students asked, how do you draw a circle? Okay, so how do you draw a circle? Imagine I asked you draw a circle, but you're not allowed to use Python circle function or Turtle's module circle function. So think about that. When I write turtle dot, I really don't know, traceback. Arrow is telling me traceback, how I can fix. I don't even know what that means. Sometimes it helps that when you have an error message that you don't understand, that you copy paste that exact message and you put it in Google, and you're not the first for sure who had the same problem. So then you're going to be luckily you may find an answer. Again, it's very difficult for me to how they say it, to debug your code, fix your code without being able to see it. It could be that one thing that I could guess, you could be, did you import Turtle library? So, you know, does your code really look like this? Did you import Turtle library? Did you install new Python? Some of the older versions don't have it, and so on. Okay. So let's go back to, let me run this. Okay, so it was, let's say, 30 sides. And we have here a 30 gone. So this was just to show you that actually, as n, you can prove mathematically that as n goes to infinity, n gone turns into a circle. And in fact, that is very easily used for displaying things on computer screen, because our eyes are not precise enough. So already with n is 30, you can see that this 30 gone looks like a cycle, like a circle. And you know that the screen actually is a grid, right? The screen is, I don't know, on your computer screen, you have maybe 3000 by 2000. I don't know what the numbers are of the pixels. So it's actually a grid. So you are restricted to be drawing things on the grid. So in fact, everything is approximated, but our eyes are not precise enough to see these pixelations So the way you actually implement things like drawing a line or drawing a circle is through these approximations of drawing a polygon with enough sides such that our eyes all of a sudden don't perceive the difference between a circle and an angle. So if you pick n big enough, you get your circle. As I mentioned already, I mean, of course, that circle function is already available in, let me show you here. If you do the turtle, you will see that it has a circle function. So you can say, oh, you know, let's draw another one. And the circle, this function here actually draws a circle. You should give it a radius. So I can say, oh, draw a circle. I can remove this, what we did, and I say, oh, draw a circle with radius, I don't know, 50. Oh, it's still asking me how many sides do I want, but that's not relevant in this case. It draws circles with radius 50. In fact, you can see that their circle is also pixelated like our n-gon, right? So you pick n big enough, and it's gonna draw you a circle, because mathematically, as n goes to infinity, for a fixed length of sides, as n goes to infinity, you are creating it tends to a circle. Okay. All right. So where are we? Okay, so in the last half an hour, we're gonna look at another concept that you're gonna be using all the time. But let me first make a pause to see if you have any questions. I'm gonna undo this. If you have any questions about the part that we have done so far. Let's see, what are the questions? Yes, that's a very good. So far so the question is, can we make a length go down? You want length, the more sides you have, you want to make a smaller length of your side, because otherwise it doesn't fit on the screen, on your computer screen or on the Python screen that get open. So this is a very good suggestion that you as a programmer could change, that you can have it such that you don't manually. So here, what we're doing, here we kind of a manual, we just, you know, saying, oh, it has to be 30, right? The length of the side. But why shouldn't we make it such that the length of the sides changes also with n, so it fits to the screen? So you want, the bigger the n is, you would like to, you know, you would like the side to be smaller. So the student suggested, I'm not sure what they suggested, but let's try something, maybe 200 divided by n. I don't know if that one will be too rough, so let's try that. How many sides? So let's say when it was a foregone, oh, it's already too small. So let me pick something. I think the student suggested something better than what I did. Let's say 600 divided by n. Okay. Let's try this one. And then you're in a better, when you figure out a good ratio, you are in better shape. So now it fits, and that's very good. And if I try to run it with a bigger n, so now if I say, oh, why don't we have 20 sides? You see, now it fits, rather than we have a fixed side, and then when I pick 20, it's too big and goes out of the screen. So that's a very good suggestion. You know, something, again, you encounter a problem, you solve the problem. Okay. Other questions? Okay. So, before I move to the next example, okay, actually, let's move to the next example. So if I have a chance, I'll give you an example of what I meant by computational problem. But first, so you learn through this, you learn the concept of a loop. How do I solve a problem, and how do I make a code repeats something a certain number of times, you know, from 4 to 8 to general n number of times. Okay, so that's what it's called a loop. So here we learn the concept of a loop. Okay, but so far our code was always doing executing all of the commands. We didn't have if this happened, do this, otherwise do this. Okay, so what do I mean by that? Maybe you want to ask a user, oh, do you want your polygon to be red or black? Something like this. So in case the user says, oh, I want red, it should draw a red polygon, otherwise it should draw a black polygon. Okay, the default one. Okay, so let's figure out how to do that. Okay, so again, from the description of the problem, we should see that we should ask another question to users. So the first we should ask, we already done, which is this one here, how many sides does a polygon have? All right. The second one is, do you want your polygon to be red? So let's ask that question. So the answer, let's say, maybe should be yes or no. We expect from the user to give us yes or no. Okay, so after getting the number of sides, we again do input and ask now, do you want your polygon to be red? I'm just trying to simplify it. Of course, you can make this much more elaborate, you know, with color and try to figure out, can you capture what they tell you and stuff like this. But anyway, let's just see. Our options are either they say yes to red, in which case we draw a red one, or if they say no, then it's a default, it's a black and gone. So we ask the question, do you, or even we specify what we want, yes or no, do you want the polygon to be red? We ask the question, don't forget to close the, so we pose the question between the quotes. And of course, we have to capture that answer in some variable, and I'm going to give that variable name answer. So this answer should contain, if the user followed our instructions, it should contain yes or no. Okay, so let's try to make sure that that works. I'm going to even remove this again, just to, I'm going to remove the drawing part just to make sure that this part worked. So let's run this and we see, why is this shell so big? And we see that we ask how many sides do you want? Okay, maybe I say 7 sides. Do you want polygon to be red? Maybe I say yes. Okay, so we should be able here now to remember in shell, you can view your variables. Take this with a grain of salt, not all variables, but the ones that we are using today, so-called global variables, you can view them in the shell. So we see that n is 7 as I entered, and that answer is yes. Again, under quote, but that's fine. Yes is a text. We want to keep it under quotes. Okay, so that part of the code works. So I come back here, undo the mistake, undo the changes I did. So what I want to do here is after creating a turtle, so here we create a window. We know this line creates a window. We know this, this command here creates a turtle that I called Anna, or called anyway. And now I want to change the color of Anna to red if the user said yes. Okay, so I want to change the color of Anna to red if the user said yes. So there should be a way in Python to test something, say if she answered yes, make turtle Anna red. Otherwise, in this case, do nothing. It's already black by default. Okay, so here's the syntax for that. Okay, so for the keyword for it, the same way in this type of loop, we have this special keyword for and in. The keyword for asking a question, if this is simply if. Okay, that's a special way to ask a question. All right, so if this answer here is yes, and again, text yes, so don't forget to put the quotes. And again, we need a column. So if the answer is yes, and those of you who know Python may see already a little mistake, don't worry about it, I'm going to get to this. There's a reason I'm doing it. So if the answer is yes, only in that case, we want to change the color of Anna. Okay, So how does Python know? So the command for that, actually, you can go into this dir turtle, you can find function color, okay, and how to use it. So I want to do Anna dot color. I want to put the color to be red, okay? But I want to execute this line of code only if the answer is yes. So how does the Python know what to execute if this is true and what to always execute? Again, is the same thing. If I put this Anna.color, if I line it up with the leftmost edge of the editor, it's going to always execute it, not just if the answer is yes, right? This line will always be executed the same way. When I did print goodbye, it will always be executed, right? So these two lines would always be executed. So if you want to tell Python execute something only if this is true, rather it's in this so-called if statement, you have to tell Python that it's part of an if statement by, again, indentation. You put it in, okay? So what this tells Python, if this statement is true, then you should execute this indented block, okay? Otherwise, if the answer was no, or rather if this is false, if this test is false, whatever is in this indented block, you should skip and just continue in the next thing that is lined up with the leftmost edge, which is in our case, the drawing thing. So if the answer was yes, we should change the color to red and then move on, which means draw this. So our polygon is going to be red. If this was false, then don't execute this, just continue with the next thing that is lined up, which was again the loop for drawing. So it's going to draw it back. Okay, so let's try that. Okay, so we get a mistake. Where is the mistake? I made this mistake on purpose. Okay, so let's run it again and see what it says. It's complaining something about equal sign. And it's even telling you where. It's over here. Okay. This is something very important to remember, and I will be repeating it throughout the semester. When you see this sign in programming languages, not just Python, it doesn't really mean equal. It means a sign. Think of it as this. You know, in some ways, we can even say that that type of syntax is programming language syntax in some ways is wrong, but this is that we shouldn't have used that, because what this equal, you shouldn't re-equal. What it does, it means assign. Whatever this creates, assign it to this variable. So this, we created a screen that we assigned to variable wn. We created a turtle that we assign to variable Anna. So that turtle is an Anna. So when you see a single equal sign, you should read assign, okay? So since a single equal sign assigns something, how do you do real equal when you're asking, is this equal to this? Well, for that, you use two equal signs, okay? So this you should read as an equal. Equal, equal, read it as equal. So this means if answer is equal to yes, change color to red. Otherwise, if this is false, if this text is false, skip this block and just continue. Okay, so let's see if we're going to achieve what we want. How many sides? I don't know, 13. Do you want your polygon to be red? Let's say I say yes, and indeed it's drawing a red polygon. Let's see what happens if we say no or anything other than yes. Let's say 7 gone, no, and then it draws a black one. Okay. So this thing here, if you haven't programmed before, at least if you haven't programmed in Python, this is your first if statement, okay? So something that is sometimes executed, sometimes not executed, depending on the test. So the syntax of if statement is you put an if word, then you have some expression that gives answer true or false. And if the answer is true, then you execute the block of an if statement. If the answer is false, then you skip it. And this block, it doesn't have to be just one command. It can be arbitrarily long, like here we had 2. So it can, anything that is indented, you're going to execute it if the statement gives you true. And if it gives you false, you're going to skip that block, the indented block. Okay. So let me see if there are any other questions. Oh. Andrew, okay, the students are there, sorry, because at some moment I got, okay, the input is case sensitive, very good, I'm glad you asked that. So here's a question that is very relevant. Programming languages are case sensitive. Yes, with lowercase yes, and yes with uppercase yes, for example, are not treated the same. So how do we fix this? So first of all, let's see that it's a problem. Okay, thank you, anonymous attendee. All right, so let's run this program again, and let's say I really want a red pentagon. And I say, okay, I want 12 sides. 12 sides, do I want yes? And I'm so excited, I say, yes, I want it. And look, it drew a black one. Okay, I go back to my code and say, why? I said yes, because what's stored, and in fact, we can see this, what's stored in that variable answer is capital yes. And you can, again, you can type any command in the shell and see what Python does. We can see, is this in Python, is this equal to this? And Python is going to tell you false. Those two things are not the same. Okay, if we, on the other hand, by the way, single quote, double quote, Python, you can use the both. So let's not get confused by that. Is yes equal to yes is going to tell you true. Okay, so as you want to be making a user-friendly programs, you want to accept any kind of yes that they give you, right? So there are a couple of ways to solve it. One kind of, let's call it old-fashioned way, because in the past, that was the only way you can say, okay, if answer is this, yes, or you will accept all of these. Or answer is this, I will accept this. Or answer is, you know, everything that you think is reasonable, you can do it like that. You say, I will accept this type of, these are reasonable, I'm going to accept them. So if you give me any one of these, if any one of these is true, then the whole expression is true. And therefore, you're going to change the color. So let's see that that works. How many sides should the polygon have? I don't know, 14 now. Do you want? And I say yes. And now it's really red because one of those was true. My whole expression was true and I get a red. And in Python, there's actually a very easy way to do this without thinking. There is a trivial, even more trivial way to do is there is a function called lower that works on strings, so any text. What you can do is you can turn this answer contains a string, okay? So rather than testing all of these possible versions of yes, you can just, before you even test it, you can say, you can call a function lower on this, on the answer. So answer is a string. In a string module of Python, there is a function called lower that turns all the letters into lowercase. And only then you do the comparisons. It doesn't matter if the user uses capital letter. This thing here is going to first turn all the letters into lowercase letters and then compare to yes. So this is another solution to that problem. Okay, so let's see. I see how many sides. Let's say we want a triangle. And I even do something strange like this type of yes, it's going to accept it because it turned everything into lowercase and accepted my yes. Okay. So that was again, the first example of if statement. And for the last problem, and before that, let me look at the questions. Yeah, so I think this lowercase, so there's a question, is there a way to accept answers that are synonymous to the words yes or no? How do we add it in the code? Oh, you mean synonymous as in yeah or sure? I don't know. Well, then you really have to, then there's no such simple answer like this lowercase. Yes, there's another suggestion there that also works, but it involves lists in Python. Today, we're not going to do lists. I mean, this is a whole semester to work with them. But I think the first student was asking even, oh, I'm willing to accept things that colloquial English mean yes, such as, I don't know, maybe you want to say, or if they say, is your answer sure? Something like that, right? Then you really have to code everything that you can think of means yes. You go to, thesaurus, you go to Webster thesaurus and you put yes in and look at all the thesaurus, what it gives you for, what are all the equivalent ways to write yes. And then you test them like this or in the list like the other student gave. But you can do something like let's say you just want to accept yes and sure. And then it would work. I can say not misspell it. It's going to accept it. Okay. So all right. But here's the last thing I want to do, because again, it's going to involve some solution, solving a bit of a thing, except that I don't know what I did with a pencil. Just a moment. Probably I'm sitting on it. Yes. Okay. All right. So let's say as a last thing, I want to make a colorful pentagon, not pentagon, engon, colorful one. In the following sense, rather than asking you, do you want a red or black? I want you that your sides alternate the color. So what do I mean by that? Let's say we want to draw a sixagon, and 1, 2, 3, like something. This would be the corners. What I want is that the first side is, let's say, black, then red, then black, then red, then black, then red. Okay, so you give me an n, or you may ask, what if n is odd? Let's say the user always, I mean, if n is odd, then you're going to have two of these colors that are the same. It's not really alternating. So you need n to be even. So assume user is going to tell you 8 or 12 or 74, something divisible by 2. So they give you that n, which is an even number, and your task is to draw engon. We have a code for how to draw that engon, but I want sides to alternate color. Okay, so that's our next. So there's no questions. Do you want, so I'm going to remove this previous part. The point was then to learn about if statements, because again, maybe here we're going to need them again. We'll see. So here's a code. So forget this question here. I don't know why I'm here creating. All right. So back to the basics. This is a code. Creates a screen, creates a turtle, asks for engon. What is your n, captures n, and draws an engon. Okay. So what we want is that somehow, this is the part that is drawing engon. So what we want is to every time you draw a line, then somehow you change the color, and you draw a segment, let's say it's black, then I change the color. So the next time when it draws a segment, it's red. Then next time you change the color, so next time it's black, and so on. So let's try to figure out what we need to do. So what is happening in this code here right now in our solution? Every time we enter here, where I put that red hash, remember those are the lines that are not going to be executed if you put a hash in front. Every time the loop returns to the beginning, this goes forward and then turns left. Okay, so first time we enter this loop, let's say I want the color to be red. Okay, the second time I enter the loop, I want the color to be black. Third time I enter the loop, I want red again. Fourth time, let's say, n is 20. I'm not going to go to 20, but, just to give you an idea, it's black again. Fifth time I enter the loop, I want red again. Sixth time I enter the loop, I want black again, and so on, depending when n is given to me. All right, so what do we notice here? When do we want to draw red segments? And when do we want to draw black segments? So let's look at it. First time we enter the loop, third time we enter the loop, fifth time we enter the loop, we want to draw a red segment. So what do these numbers have in common? As Taha told us, every odd time we enter the loop, we want to draw a red segment. Even on even times, we want to draw black segments. So if we want to solve this problem, if we know how to test, am I entering the loop for the odd time or even time, then it's easy. I say if it's odd, change it to red. If it's black, if it's an even number I'm entering the loop, change it to black. Okay. Let's say that, let's write that even though we don't know how to test if we are entering, we have to still figure out, how do I test if I'm entering the loop, the odd or the even time? Okay. Okay, so we see here that, even time. So if on every even entrance of the loop, I'm inventing the words, the color should be black. Okay, so let's try to code this, even though we don't know it. All right, so when I'm inside of the loop, let's write this in English. If eventh time we are entering the loop, I'm going to put it in comments because we don't know how to test this yet. But imagine we know this. So leave this as a placeholder. We still have to figure out, how do I test that I'm entering the loop, the even number of time. But so I'm going to leave it as a comment and say, I'm going to write the code in the comment. If I knew how to do this, if I'm entering the even time, we have already seen this, how to do it. And color red. By the way, before we even get to this, here's often what, first time you try this, you may be tempted to do, okay, I'm going to do an color red. So I change the color to red. I draw this segment and now I change it to black. Okay, you may think this works. You should ask, but this is one of the things. And even in fact, in order for me to understand, do you understand what's going on? This is a type of a question I may ask you in an exam. What does this draw? And the answer should be in English. This draws red and gone, red, black, black and gone, or this draws and gone where red and black are alternating. Which of these statements is true? So answer, all of you, look at this code, this thing here. And suppose I ask you a question. This piece of code, given even integer n, which of the following statements is true? It draws regular angon, black regular angon, A, B, red regular angon, that's answer B, or C, regular angon where red and black sides alternate in color. So which of these statements is true? Red angon, black angon, alternating angon. Okay, so the code is there. I have some answers. Red, black, alternating. Only red, exactly, because, you know, try to see what this is doing. You have to make a distinction between what you want and what you actually told the computer to do. Because look what happens here. You enter the loop for the first time, the color, you set the color to red, you draw the red segment, and then you change the color to black. You did change it to black, but then this code is repeated again because we are in the loop. So this whole code is repeated again. So right after you change the color to black, you come here and change it back to red. So again, right before drawing a segment, you change the color to red. So this is going to draw red. It's going to draw a red polygon. You can run the code, this code, and you will see it. So this definitely doesn't work. This would be a guessing type of coding, right? You guess, but it's better to guess and try even through guesses, through wrong guesses. You're going to learn a lot if you try to figure out why did this not work. Okay, so let's go back to our previous if thing, our previous logic where we were kind of more detailed, and we said, if we are entering the loop even number of time, then change the color to red. And there is, we previously saw in if statements which only had an if, but there is a version of if statement which says, if this is true, do this block, and then you have a keyword else. So if that's not true, do something else. So here's piece, you know, let's keep our code like that. And then I do else. So if this is not true, if we are not in even, I was adding, so there's a question why I add commented out. I was commenting this out. If you put a hash in front of a line of a code and then you press run, the program is not going to execute any line. So that means you're commenting it out. It's not going to execute any line where you have a hash in front. Okay. And then it goes, you know, the question is, why did I do this? I was just doing it in case we want to run it. Because if I leave this like this, it's not going to run. Python doesn't understand what this means. Even time, even you know, without my explanation, you wouldn't know what I mean. Okay, but I'm going to leave it. I'll show you it's going to crash. So if we are not entering the even time, that means we are entering the odd time. So we should use else. So this is another form of if statements, if else. Otherwise, so red, otherwise black. So if we are entering, so if this is true, we are entering even time, then execute this block and skip that. That's what this syntax means. If this is false, then you're going to skip the true block and you're going to execute the false block. Okay, meaning it's not even time. We are in odd time, so I should put the color to black. So the person asked me, why did I put a comment here? Because if I don't, this doesn't exist. This is not going to run. It's going to give you syntax, invalid syntax. Doesn't know what I mean by this. Okay. So this actually is a correct solution conceptually. It's a correct algorithm, except that we don't know, we haven't solved this. How do you test that you enter the loop even time? That's the only thing missing. Everything else is correct. If I know what to put here, how to test that we are entering the loop even time, then we would be done. All right, so how do we do that? To figure out how to do that, let's look at something that is super useful to know in terms of syntax and how Python works. Let's finally figure out what this variable I is for. What is in this loop, what is this variable for? So I'm going to put aside this. I'm going to comment it out. And I want to know, what is this variable I? Okay, let's try to do it. I want to print. One of the way, if you don't know what something is, it's very useful to just print it to see what it is. So print, the same way as we were printing text, you can ask to print what's in that variable. So now we have this here, we have, so to avoid confusion, I'm gonna even, okay, I'm gonna comment this out. I don't even want this to be asking you for n. I wanna say, let's say this is 8. I'm gonna repeat this loop 8 times. I wanna know what is the function, what is this variable I doing? Okay, how does the loop keep track of where you are in the count? So let's figure out. So we encounter here, here we have a loop, and we tell Python, repeat this 8 times, print I 8 times. So let's see what's gonna print. There it is, you see it here. It prints 0, 1, 2, 3, 4, 5, 6, 7. So it prints 8 numbers. So in fact, that variable is keeping track of your counting, where you are, how many times you're entering the loop. Except that unlike humans, computers start counting from 0. That's why it's printing 0 to 7. So you want to repeat something 8 times, it's doing 0, 1, 2, 3, 4, 5, 6, 7. So that variable I is keeping track, it's counting how many times you enter the loop. Okay, and it's going to enter it at most 8 times. That's what it does. So now we know that what we have in I, first time we enter the loop. So let's look at it. What was printed first? It was 0. So first time we enter the loop, I is 0. 0 is an even number. Next time we enter the loop, I is 1. That's an odd number. Next time we enter the loop, I is 2, another even number. So I is keeping track of how many times we're entering the loop. So we should test, is I even or odd? So in this code, rather than using this terrible English, I can now use a bit of better English. Still English. If I is even, if I even number. If I is even number, this is still not going to work. I mean, this is still only English. Python doesn't recognize this. Okay, invalid syntax. But conceptually, this is correct. If I is an even number, set the color to red, otherwise set the color to black. Okay, so there's one last thing to do. How do we figure out if a number is an even number? What's the test? What is the definition of number being even? Okay, hopefully you all know this. And by the way, this we're going to use all the time, not just for even numbers, for everything. Okay, so the definition of what a number is even if it's divisible by 2. Otherwise, it's not even. And what does it mean to be divisible by 2? It means that when you divide, when you do integer division, there is no remainder. Remainder is 0. Okay, so you had, remember when in first or second grade, or basically first time you were learning division, you only knew about integers. When you start in school, you don't know other numbers. You don't know 2.14, you don't know pi, you only know integers as a kid. And that's a problem when you, so it's fine when you're doing addition, subtraction, multiplication, it's all fine. But then you get to division. And now it's not fine anymore. You know, they can teach you 6 divided by 2 is 3, and 8 divided by, you know, and 9 divided by 3 is 3. What about 10 divided by 3? So the way they teach you this, they say 10 divided by 3 is 3, and there is a remainder 1. So you are learning about integer division before you even learn about rational numbers. So there was a concept of remainder that you learned in, I don't know what grade in Canada. Okay, so let's go there. So the number is even if when you do integer division with 2, there is no remainder is 0. So what you want to do is test. If you want to know if the number I is even, what you want to do is you want to ask, is the remainder of division of I with 2 is the remainder 0? And all the languages have an operator for asking for that remainder. So let's look how you do this in Python. Let me just run this. I don't know. Oh, of course, even syntax is wrong. Let me open a shell. I don't know why it's not. Just a moment. I'm going to comment all of this out. Just because I want to open a shell. All right. All right, so we are in the shell. Here in the shell, let's try that. So this is how you do integer division in Python, pardon. With this is normal division. 4 divided by 2 is 2, 5 divided by 2 is 2.5, okay? But with integer division, 4 divided by 2 is 2, and 5 divided by 2 is 2, but there is a remainder. And you can ask, what is that remainder? And that operator is this symbol, the percentage sign. That means remainder. So this means give me a remainder of division of 5 and 2, and that's, and that's 1. Because 5 is not divisible. 5 is, remainder is 1. 5 is not divisible by 2. What's left over after integer division? Remainder of division of 4 and 2 is 0, 6, and 8 and 2. So every even number, the remainder of division with 2 is 0. So to test is I is even, we just need to test is remainder of division with 2. Is it equal? Remember, equal, equal. We are now asking, are you equal? Are you equal to 0? All right. So there it is. Now we have a proper test that Python understands. This test is I an even number. And the number is only even if the remainder of division with 2 is 0. So let's see if that finally works. How many sides? Let's pick an even number, 10. And now you see that we have we have a polygon with alternating colors. Okay, so let's see. And one thing that we learned through this is a concept, another if statement, but a form that has an else part. So if else, right? So if you have a test, every if statement, you have to have a test that gives true or false. Right? So you have a keyword if, then something that the answer is true or false. If the answer is true, it's going to execute the first block. If the answer is false, it's going to execute the else block. Okay, so that's why a solution works. So let me look at your questions now. Only read, only add. So that was good for the first part. And of course, many of you know how to test. Or this was test for the odd number. So if you want to test if the number is odd, then you can say this is 1. Odd integers have remainder of division 1. That was done. Okay, so this is a very good question a student is asking, why does it automatically increase? Don't you need something like I+1 or I++? So all of you pretty much who programmed in other languages, you have seen the concept that in order for this I, we were printing I, and you saw that I was changing from 0 going up by 1. In other programming languages, you have to somehow do it yourself. You have to say I+1. Inside of the loop, you have to be increasing I. And you have that in Python in while loop, not in this type of loop. So this is just, Python has a different syntax. So you don't have to, in the for loop, so what's different, and it's actually really great, you will see with time, that's quite useful. I mean, most of the time, that's all you want. What is increasing I by 1 is this range function. So range is simply a function that if you give it an integer, let's say 10, it produces a numbers starting with 0. So range is a function that every time you execute it, gives you the next integer. So if you do range 10, it's going to produce 0, then it's going to produce 1, then it's going to produce 2, then it's produce all the way up to n. So it's going to go from 0 up to n. So if you give it n is 10, it's going to produce numbers from 0 up to 10, which means it's going to produce number from 0 to 9. Okay, so it's simply different syntax. You don't need to increase I by yourself. The range function does that. So what this does actually, what this loop does here, first time you execute this line, this loop, range produces 0. So let's say it was range 8, like we had. Range is going to produce 0 and assign it to I. So when you enter the loop and do print I the first time, it's going to print 0. Next time you come back here, because it's a loop, it's coming back, range is going to produce the next number, which is 1. And then it's going to assign that number to I. So next time you execute that first line, it's going to assign 1 to I. So when you come here, it's going to print I is going to be 1. So it just works in a different way. You don't have to change I by yourself like in other languages. Okay. What's the next question? Yeah, so that was again the answer. Somebody knew the answer. Where will the video be after session? If you were at the beginning, you would know. I'm going to, so here again is my name. First of all, so if you're not in my section, I will, first of all, the link to the video will be posted on Brightspace. So all your courses will be on Brightspace, and especially in first year. Sometimes professors choose not to use it, but I think all of your professors will use it. So on Brightspace, I will post a link, not today, within the next 24 hours, I will post the link to the recording of this tutorial. And you can find a link on Brightspace. And for those who are not in my section, I will give the link to your professors and ask them to put it on Brightspace of your course. Alternatively, you can find a link by yourself, but again, not today. So try in about 24 hours to put Vida Dujmovic YouTube, and I'm going to put this recording on YouTube, and it's going to be public. So you will be able to find it. Yes, so, okay, and finally, the last question that I have here is, so if I understand you properly, you added a hash simply because you knew that the code would crash. Exactly. So sometimes you maybe want to type something, I'm typing it to explain concept to a student, but I'm going to put a hash because I know the code. If I want to run a code, I know it's going to crash because I haven't finished teaching it. So the next question is, I know you mentioned that any computer would be fine, but I want to ask for your advice on the best computer for business technology management plus computer science. I'm considering purchasing a Mac and a Windows desktop. One of the students I knew mentioned that a gaming PC would be great choice for coding and schoolwork in general. Do you think a gaming PC would be beneficial for coding, or would any option be better suited? Thank you again. I really am sticking to my answer because I really believe that any machine, if you want a gaming machine because you're going to play a game, that's going to be perfectly fine. If you want Mac, that's going to be perfectly fine. I don't think we have any, I don't know, maybe you're in some really special, maybe I have chemists, so I don't know who, or people doing mechanical engineering this class that are going to use later on some specialized software that they only use to look at the structure of the stones and it's only available to Windows. I don't know that, but in my experience for computer, well, you did ask computer science and business management, I think you would be fine if you want to have a Mac. So it's really, again, up to you. Okay, so I have another question that I already answered, whether the whole course will be in Python. Yes, your first semester programming course will be in Python, and your in the second semester course, ITI 1121, will be in Java. So the first course is fully in Python, and the second course will be fully in Java. So somebody is giving advice not to get a Mac because some applications might not work. I'm not sure I agree with it. Why would you support? And anyways, your choice, guys. I went through the whole school with Linux because I absolutely hated Windows. I didn't want to, I didn't want to use it. I still think it's really not a very pleasant operating system. But again, it's up to you. I went through the whole schooling on Linux, not on Mac, not on Windows. Admittedly, if you buy a Windows machine, in fact, even Mac, if you buy it, you can install Linux. So you can have a dual boot. That's what I was doing at some point. You have dual boot. So when you're booting your machine, you can choose, do you want Windows, do you want Linux, and so on. There is a question, do we need two different PCs, one desktop, other laptop? Absolutely not. Don't waste your time. If you find working on laptop, don't spend money on buying desktop as well. Okay, so for the last thing, so in the meantime, you can type a few more questions. The last thing I want to give you indication of, and it's kind of more of a global story of computer science and what kind of Linux I used two kinds, but this one really talked about a long time ago. I used Red Hat first, then I used Ubuntu. It really doesn't, I love Linux. I just became lazy at some point for installing it myself, although later on in years, it became trivial to install, and it's really great. Is it normal if my lab is before my lab lecture? You're not gonna, I already answered this question. The first week, the class starts on Wednesday, and at least my course, ITI 1120, you're not gonna have labs in those first 3 days, even if your schedule said so. Okay, so you're not gonna, the labs will start the week after on Monday. Okay, so before I answer some of these questions that I hear, this one I answer, I'm gonna leave you. This one I already answered. Okay, I'm gonna leave this. I'm gonna get back to it. What I wanna just mention for the end is what I was mentioning. Why you are here? Why you're studying this? Just even pay attention to the first thing. The course is not called Python. It's not even called programming. The course is called Introduction to Computing. And your next course is called Introduction to Computing 2. This one is called Introduction to Computing 1. And there is a reason why it's called Introduction to Computing. The whole goal is, again, to be able to solve computational problems. Throughout this process, our goal is not that you memorize anything, is that you learn thinking of yourself and start developing solutions for yourself to computational problems. So now I want to give you an example of what I mean by that, because so far, when we are coding the beginning, I can only give you some trivial things. So let me give you examples, and examples have nothing to do with, and this is going to be the last thing we're going to end the lecture. I think it was even scheduled to end at 2 o'clock. So, and this is going to be a short example. I want to give you an idea of what that means, and it has nothing to do with the programming languages. It has to do with developing solution procedures of how do you solve something. So suppose, here's one procedure, and it's not going to be the one suppose I'm an employer and I'm really rich and I have some stupid task that I need done. And the task is I have, I don't know, 1,000 cards, like cards for playing games. And on these cards, on one side are numbers, let's say integers, but the cards are facing down. They are in line and they are facing down, and there are numbers on the other side. And then the person says, oh, and forget 1,000. Let's say there's 100,000 cards. And they say, oh, I'll pay you, I don't know, flat fee, but you have to tell me, is number 830 on one of these cards. Okay, there you have a line of cards, they're facing down, and you're desperate for money. You say, oh, they're going to pay you really well. I don't know, $2,000. You have to tell me. And what you're allowed to do is you open one card at a time to see if 820 is there. Okay, and ask you, how do you solve this problem? What's the procedure? Well, in this case, the procedure is really trivial, right? You open the first card, is it 820? Oh, it's not, you put it down. Yeah, it has 100,000 cards. There's no more boring job on the planet. You may, so the procedure is very simple. Open the card, first, second, third, fifth, open and compare with 830. That's your procedure, that's your algorithm. You open the card one by one, compare with 830. If you find 830, you can stop, collect your money. Otherwise, you can only stop when you open the last card. Okay. You may ask yourself, so that's your first goal. This is a stupid problem. Don't think, actually, this is not a stupid problem. This is one of the most fundamental, stupid in the setup that I gave you. This is one of the most fundamental computer science problems there exists. It's called searching. And whether you know it or not, you are doing it repeatedly, multiple times a day. Every time you search something on Google, you're actually doing searching. You may think, but it's a text, but everything on a computer is represented by a number. So this is actually, and my model where you're entering the card, that's what computer is doing. It's reading some memory location, is opening to find what you're looking for. So you really hope you don't have to open it. So your first goal is, what's the procedure to solve something correctly? Your second goal is, can I do this better? Can I do this by not looking at all of the cards? Okay, so put the search on the side. And in fact, you cannot do better unless you know something by the cards, maybe that they're sorted. Then you can do much better than looking one by one. You can ask yourself, what's the procedure? A better procedure. If you knew, still 100,000 cards, you still have to answer is 830 there, but don't make any assumption. There's maybe million, minus million. You cannot make assumption what are the numbers on the cards, but you know they're sorted from smallest to largest. Give me a procedure, correct procedure, but maybe one that doesn't open all the cards. They open way less cards, so you're done way faster to collect your money. But here's someone, okay, leave it aside, but here's my working example. Let's go back to, I give you 1,000 cards, numbers, there's 1,000 only. They're facing down, and the person that is paying you, all they want is for you to answer, are there 2 cards that have the same number? At least 2 cards, okay? In other words, is there somewhere, I don't know, 5th position and 100th position, maybe I open 2 cards and they have exactly the same number. This is called a duplicate problem. So I give you 1,000 cards facing down. I ask you, give me a procedure. So first, correct procedure. That's what I mean. That is a computational problem. You have n cards. In general, it's going to be n, but I'm telling you 1,000. So give me a procedure, solve this. This is computational problem. Find a procedure that correctly decides yes or no, are they duplicates? So at least 2 cards that have the same number in the given set of cards, in the given bunch of cards. Okay. So this is example of computational problem. Your goal is to come up with correct procedure. This is called algorithm. Once you have a correct algorithm, it's only then you translate it. You call it, then it doesn't matter what language. When you're switching, once you learn Python, your next course is going to be Java. So it's not like you're going to go back to the beginning and repeat my course, but it's going to be in Java. No, you're going to be given like 2 weeks to get used to syntax, and then you're going to continue. And that's reasonable, because what you're doing, you're developing problem solving. Once you know how to problem solve, you just translate to another programming language. So what you're doing is you're translating your solution, your algorithm, into a programming language. So let's go back to what we're looking at. You are paid, you have lots of cards, let's say 1,000, 10,000 cards. You can go home once you can correctly answer, are there at least 2 cards that's showing the same? And rules of the games are, there's no eyeballing. It's not like I can open the whole card, I'm going to eyeball it. Then I'm going to say, I'm going to give you 1,000,000 cards. There's no way you can eyeball 1,000,000 cards. The rules of the game, at any one time, you open 2 cards, you compare them. If they're the same, you can stop and collect your money. If they're not the same, you put them back down, face down, and pick new 2 cards. Okay? So then you need to give me an algorithm. Give me a solution to this problem. Okay, so maybe in some of you, binary search was for searching. So the first thing is give me a correct procedure and specific procedure. No eyeballing for the humans can eyeball small things, right? So that's what your algorithm is. First, give a correct procedure, how you find duplicates. And then you want to find the fastest possible. So here's one trivial thing, and I'm going to say it fast. It doesn't sound, to figure out are they two the same, you can so-called compare all the pairs. Your algorithm can say you open every possible pair and compare them. Okay. It doesn't sound so bad. There's 1,000 cars. And then you may say, how do you create every pair? How do I know how to compare every pair? Then you can say, well, your procedure would be take a first car, compare with the second, first with the third, first with the fourth, first with the fifth. Once you compare first with everything, you're done with the first. Then you take a second, compare second with the third, second with the fourth, second, and so on, right? It doesn't sound too bad. That's a correct procedure. All right, but let's look. You're comparing all the pairs. There's 1,000 cars. All the pairs, that's roughly 1,000 squared. It's already a million operations. So to collect your money, if there are no two that are the same, you're going to end up flipping a million pairs to figure out are they two that are the same. Then you desperately may want to say, can I do this better? Can I compare less pairs? Okay, so that's your next thing. First, solve the problem correctly, then solve them with less operations. Okay, so can you solve duplicates better than comparing all the pairs, which is quadratic? And quadratic gives you a million comparisons already when n is 1,000. So that's why you hear, that's what you're going to study, how you solve computational problem, how you solve them efficiently.